Namaskar. This is VIKRAMSINGH CHAUHAN, PGT Physics, Nandidya Niketan, Jamnagar. Welcome you all. In our previous videos, we had discussed the concept of speed and velocity, concept of acceleration, concept of the kinematic equations. We had applied kinematic equations to solve some numericals. Today, in the chapter Motion, we are going to study about the graphical representation of motion. When an object is in motion, we will restrict ourselves that it is in linear motion. The object is moving along a straight line. If it is moving along a straight line, the terms like distance, displacement, velocity, acceleration, time can be related to it. Now, if one variable is fixed, one quantity is fixed, like time is fixed, then at different times the velocity of the object, the distance covered by the object, the acceleration of the object may get changed. And in a question, if it is given that the object is moving with certain velocity, is accelerated with certain rate, what was its position at a given particular time, then the numerical approach to this may take some time, and to avoid this we can use the graphical representation of motion by plotting a graph between distance and time, distance time or velocity time or acceleration time. We can readily find out the position of the object at a given instant. I'll show you that part. Basically, there are three types of graphs: distance time graph, velocity time graph, and acceleration time graph. But since in our course only two are there, distance time graph and the velocity time graph, so we will restrict ourselves in that particular part only. The first type of graph is distance time graph. This is also called as position time graph. And since the motion is along the same straight line, we can also take it as displacement time graph, because the magnitude of displacement is equal to the distance covered. So, possible cases are there. Like the first one, let me just take one more minute. A distance time graph is the plot between distance and time. Usually, time is taken along x-axis and distance, which is variable, is taken along y-axis. So depending upon the nature of the motion of the object, we can have 3 to 4 different cases three basic cases we are going to take here. Since the plot between distance and time, the graph between distance and time, we will take time along x-axis and distance along y-axis. The first case can be as distance time graph when the object or the body is at rest. Now let us consider object is at the origin. That means the initial position of the object is at the origin O. This is our y-axis, x-axis. We will take time in seconds along x-axis and distance or position of the object along y-axis. Now when time t is 0, the object was at the origin. Since it is at rest, after certain time when we will observe t equals to say 5 seconds, 10 seconds, 20 seconds, the object will remain at the origin, and that's why each time we are going to get the points of position, they will come along x-axis. When the object is at the origin and it is at rest, then the graph between distance and time for the object at rest will be along x-axis, or we will call it as along time axis. It will be parallel to the x-axis. This was the case when the object was at origin. Now, in the same part, let the object is at a certain distance x from origin, or you can take s also here. In this case, the graph will come. Suppose the object was lying at this distance. This is the distance x or s. From origin, the object was here. Now, this is our y-axis, x-axis, time along x-axis, distance or displacement along y. So when time t equals to 0, the object was at this position. When time t is equals to 5 seconds, we will get the object will remain there only in this way. Doesn't matter if we are taking the observations for certain long interval of time, then also the object is not going to change its position, and that's why the distance time graph, ST graph, for the object which is at a distance x from origin is a parallel line, is a horizontal line parallel to the time axis. It is horizontal line parallel to the time axis. There is an important property that we will come across in the next part, where the slope of this line with x-axis. In both the cases, the slope, the tilting of this graph with respect to x was 0. It is parallel, so we cannot take the part here. But in the next part, in next case, we will see what is the slope of a graph. So these are the two cases when the object is at rest. The graph ST graph is a line parallel to the time axis or parallel to the x axis. Now second case we can take as when the object is in uniform motion. ST graph when an object is in uniform motion. We all know what is the uniform motion. When the object is in uniform motion, it covers equal distances in equal intervals of time. That means if in first 5 seconds it is covering 10 meter of distance, in next 5 seconds also it will cover 10 meter, 10 meter, 10 meter distances. For example, we will take time and position of the object. Say 0 seconds, the object was 0. It was starting from the origin say. Then after 5 seconds it covered 10 meter of distance. 10 seconds the object reached to 20. 15 seconds the object reached to 30. 20 seconds the object reached to 40. This is the distance in meters say. And take 10 meter, 20 meter, 30 meter, 40 meter. 5 seconds, 10 seconds, 15 seconds, 20 seconds. So this is the tabular form of the observation that are done for an object. We can plot the graph, ST graph, for an object in uniform motion, that too starting from the origin. So in this case, time will come along x-axis, distance covered will come along y-axis. This is the origins. When time t was 0, displacement was 0. The first observation. So the first point will come here. After 5 seconds, the object has reached to a distance of 10 meter. So our point will come here. After 10 seconds, the object reached to a distance of 20 centimeter. So our point will come here. And in this way, at 15 seconds, the object will reach to a distance of 30 meter. All these points, they can be taken on the graph paper. And thus, if I join these points, it will be a line which will be in a slanting form. This is the ST graph. The line OB is ST graph for an object which is in uniform motion starting from the origin. Here, the angle made by this graph, line OB with x-axis, can be written as theta. Greek letter generally used to measure angles, theta. So this is the angle made by the line OB with x-axis. In earlier cases, the line was parallel, so the angle theta was 0. Now, the angle is non-zero. The line is slightly tilted with x-axis, and importantly, the slope of an ST graph or position time graph gives us the velocity of the object in a given time interval. You put a star to this, repeat this twice, thrice, 4 times, that the slope of an ST graph gives the velocity of the object in the given time interval. What does this mean? Slope. What is the slope and how to calculate the slope? Suppose we want to find out the velocity of the object in the interval 0 to 5 seconds. So, in this case, if I want to find out the velocity in 0 to 5 seconds, this will be the time interval delta t. This will become t1, this will become t2, s1, s2. Thus, slope is equal to slope of an ST graph is equals to slope of OB, I write, is equals to, this is called as tan theta. Tan theta is a trigonometric ratio. The side opposite to the angle divided by side adjacent to the angle. That means, in this case, it will be y, or I write it as delta s delta t. So this will be equal to delta s upon delta t, or can also be written as s2 minus s1 divided by t2 minus t1. So in this case, in the interval 0 to 5 seconds, if I want to find out the velocity of the object, it will come as v is equal to s2 minus s1. This is 10 minus 0 divided by 5 minus 0. It will come 10 upon 5, that is 2 meter per second. In this way, if I want to find out the velocity in interval 0 to 10 seconds, then this will become delta s upon delta t. That is 20 minus 0, 20 minus 0 upon 10 minus 0, that is 20 upon 10, 2 meter per second. Not only this, if I take the third one, the interval 0 to 15 seconds, then also we will get 30 minus 0 upon 15 minus 0, 30 upon 15, that is 2 meter per second. In all the cases, since it is the uniform motion, the object is moving with uniform velocity of 2 meter per second. It is covering equal distances in equal intervals of time. I hope you have understood the concept of ST graph for an object in uniform motion. I am repeating, the slope of an ST graph gives us the velocity of the object in the given time interval. Now, this was the graph for an object which was starting from the origin. If I want to draw a graph for uniform motion, but the object is not starting from the origin, then the graph will come like this. Suppose this was the initial position of the object when time t equals to 0. The object was here, and then later on it had covered equal distances in equal intervals of time. So again the graph will be same. The graph is a slanting line making certain angle with x-axis. I draw a parallel line here. This is the angle made by this line with x-axis. So the nature of the graph is not going to change. Only since it is starting from certain different position, so we are going to get the graph starting from any arbitrary position, the given position, say A. Line will become AB now. Slope of an ST graph gives the velocity of the object in a given time interval. Now, the third case that we can take as the third case of an object is ST graph, position time graph for an object when it is non-uniform or accelerated motion. Now the distances covered by an object are not constant. They are increasing with time. For example, t in seconds and s in meters. If I am taking time t equals to 0, we will take the same 0, 5, 10, 15, 20. And the object is starting from the initial position, say 0. Then in the first case, if it is covering 5 meter of distance, then in next part, if it is covering 20 meter of distance, 45, and then 80 meter of distance. So clearly the object is not in uniform motion. The object is covering different distances in different time intervals, and thus the graph between these two, time along x-axis, displacement or distance covered along y-axis, origin. When the first point will come here, since the object is starting from the origin. Second, 5 on a scale, on the graph paper we will take 5, 10, 15, 20, 25, 30, 35, 40 seconds. So the first point, after 5 seconds the object will reach somewhere here. Then at 10, after 10 seconds the object is going to 20. And after 15 seconds the object is reaching to 45. This point is going to come somewhere here. On the scale, you can plot it. So now, if the points are joined like this, the motion of the graph is not a straight line that we had seen earlier. Instead, it is a curve, and the curve is in such a way that it has a positive slope. Suppose we want to calculate the velocity in this particular interval of time, then it can be drawn by drawing a tangent here. Draw a tangent and find out the slope of this tangent. This is the angle theta. Clearly, in this case, we will need to find out the velocity of the object in small intervals. And thus, I'll draw it once again. The graph is going to appear like this, and if a tangent is drawn here, then the tangent will have a positive slope. This will be the angle theta c. The interval can be taken approximately, this will become delta s, this will become delta t. So delta s upon delta t will be the velocity in a small time interval. Clearly, this is the graph for an accelerated motion. At the instant we will skip this part of finding velocity. The graph appears exactly in a curve. The distances covered, they are keep on increasing after the time interval. Now, in this case, slope is positive. So, we can call it as acceleration is positive, or this is acceleration. All the three cases can be merged in a single graph. Like if the object is having uniform acceleration, positive acceleration, then A is positive. If the graph is a straight line, then A is 0. And if the curve is bending inwards, then this is A is negative. That is, this graph is for acceleration, the upper one. This graph is for retardation, and this graph of straight line is for uniform motion. I hope you have understood the concept of graphical representation of motion using ST graph. There are three possible cases: the object at rest, the object in uniform motion, or the object is in non-uniform or accelerated motion. Our second point is the graphical representation using a velocity time graph. You try it out, take the different data from your textbook and try to plot the graph using graph paper. On graph paper, you will find these points clearly. Take the proper scale and then plot the graph. So your answer is going to come correct. In each graph, you can also calculate the slope. You can also calculate the velocity of the object in a given time interval. So now let us take the second part of the same, that is the velocity time graph. Now the velocity time graph. Second part. Is plotted by taking velocity along y-axis and time along x-axis. A velocity time graph will also be called as VT graph, and one after the other we will study the three cases of the same. First is when the object is in uniform motion. Suppose an object is moving with a constant velocity v. Since the motion is uniform, at time t equals to 0 the velocity was v meter per second. Then it will go on increasing the distances, the intervals, time intervals, 5, 10, 15, 20 and so on. This velocity is not going to change. That is, we will get a horizontal line, a straight line parallel to the time axis. And as this line is parallel to the time axis, so slope with x-axis is 0. This has an important property here. As the slope is 0, the acceleration of the object when object is in uniform motion is 0. So this is the first type of graph in which velocity time graph for an object in uniform motion. It is a parallel line parallel to time axis, line parallel to x-axis. This is our x-axis and y-axis. Now, if the area under this graph is calculated, then area under VT graph gives the distance covered by the object in the given time interval. So we can just find it out. Area under a VT graph gives the distance covered by the object in the given time interval. So in this case, for example, t is 5 to 20 seconds and velocity v is constant. Let us take v is 20 meter per second. So distance covered s is equals to area, the shaded area, I take it area under VT graph this area can be calculated as this distance we are taking 20 into 15 to the 300 meters. Area under a VT graph gives us the distance covered by the object in the given time interval. This is the rectangle that we have taken. That's why the area of the rectangle we have chosen as the length multiplied by breadth. 20 multiplied by 15. This is 300 meter distance the object will cover in the interval 5 to 20 seconds. Next is when the object is in constant acceleration. When the object is moving with constant acceleration. The object is moving with constant acceleration. So, when the object is moving with constant acceleration, for example, we are having time t in seconds and velocity in meter per second. 0, 5, 10, 15, 20 are the time intervals that we are going to consider for the observation of motion of the object. And in this case, if the object is starting from rest, initial velocity will be 0 and then the velocity goes on increasing, that too at a constant rate. For example, 0, 10, 20, 30, 40. At time t equals to 0, the velocity was 0 meter per second. At time t equals to 5 seconds, the velocity was 10 meter per second. At time t equals to 10 seconds, the velocity was 20 meter per second, and in that way it just went on increasing. So the graph between velocity and time can be plotted like this, starting from the origin time t in seconds, velocity along the y-axis. Origin, the first point will come here, then 5, 10, 15, 20, 10, 20, 30 and 40. So we are going to plot a graph between velocity and time in this way. The first point will come somewhere here, 5, 10. Second, 10, 20. Third, 15, 30. And the fourth point here. If all the points are joined, they will appear as a straight line. This is a graph similar to the uniform motion ST graph. In uniform motion, in this case the acceleration is there and the graph is making certain angle theta. This line OB is making an angle theta with x-axis. This theta, this inclination with x-axis can be taken into consideration as the slope. As ST graph gave the slope of an ST graph gave us the velocity, the slope of a VT graph gives us the acceleration. I'll write it here, slope of a VT graph, velocity time graph, gives us acceleration of the object. Repeat it twice, thrice. Slope of a VT graph gives us acceleration of the object in the given time interval. Suppose we want to find out the acceleration in this time interval, 5 to 15. So I will take these 2 points. 5 to 15. 5 will become T1, 15 will become T2, 10 will be V1 and 30 will be V2. This portion will be delta V and this portion will be delta T. So, slope of line OB is equals to, we will write it as tan theta is equals to, this will come as delta V upon delta T, or V2 minus V1 upon T2 minus T1 is equal to the acceleration of the object. For example, when T1 is equals to 5 seconds, T2 is equals to 15 seconds, velocity V1 will become 10 meter per second and velocity V2 will become 30 meter per second. So we get slope is equals to acceleration A equals to, this will come as 15 minus 5 divided by 30 minus 10. I am writing it directly, 30 V2 minus V1 divided by T2 minus T1. 30 minus 10 divided by 15 minus 5. The answer will come as 30 upon 20 upon 10. That is, acceleration will be equal to 2 meter per second square. So, clearly a velocity time graph can be plotted between velocity and time by taking velocity along y-axis and time along x-axis. The slope of a VT graph represents the acceleration. The area under VT graph. Suppose I want to calculate the distance covered in this time, then I will have to take the area, this area first, area this one, area of triangle plus area of this rectangle. This will be the distance covered by the object in time interval 5 to 15 seconds. So repeating again, for an ST graph, the slope of an ST graph is the velocity, whereas the slope of a VT graph is the acceleration of the object. The two cases that we had taken into consideration, the object was moving with uniform motion in the first case. So area under the VT graph, we had calculated the distance covered. Here also the same thing can be done. Area under a VT graph can be calculated and that will give us the distance covered by the object in the given time interval. Now, the slope of a VT graph will always give us the acceleration of the object. Why am I repeating this? Because these are the important points related to the graphical representation of motion. Next, the third case of VT graph is that the object is in variable acceleration. VT graph for an object which is moving with variable acceleration. The acceleration is not constant, and thus this is a simple case in which the acceleration, if it is not coming constant, then the graph may be like this, the curve. In each time interval, the rate of change of velocity goes on increasing. One x origin. See, the first interval, second interval, and in this way the rate of change of velocity goes on increasing. Thus, we had studied the graphical representation of motion. I insist you to take different cases, take the tabular data and try to draw all the graphs. Try to find out the slope, try to find out the area using the graph papers. This will give you a clear idea about the graphical representation of motion. Thus, this is time to take your leave. This is VIKRAMSINGH CHAUHAN, PGT Physics, Nandvidya Niketan, Jamnagar. Thank you very much.